good morning. I'm Joanne. I will be teaching today's first lecture. And then, so today I'll be talking on Git. And I know some of you guys are already familiar with Git. If that's the case, I promise that this will not be too boring. And to start off, I will actually do a short review. How many of you guys are familiar with command line here? How many of you guys are not? So a few of you guys, I want to get everyone on the same page. So like in the next 3-ish minutes, I'll go over some really basic tools in command line. So don't worry, it'll just be a very short time. So to start off, you guys all have this thing called command line on your computer. You can open it. And on Mac OS it's terminal. On Windows it's a slightly different thing, but it's still a command line, so you can still use it. That makes sense. You don't have questions so far. Alright, cool. Alright, so when you open the command line, it looks something like this. And what you can do is you can type a bunch of commands into it. So the first one you can try is called pwd. It's called print working directory. And what that does is that it tells you where you are in the directory explorer. Yes?
So, if you guys are on Windows and you're using the command line, cmd, pwd and these commands will not work for you. You'll get an error. So if you have downloaded Git, there will be a tool on your computer called Git Bash. Git Bash will be your friend because it will do these commands for you. And all Git commands will work on Git Bash as well. So if you're on Windows, make sure you download Git off their website and use the Git Bash tool. And then the web tool will get started.
Also,
yes.
to interject, if you don't have Git Bash, you can also, okay, never mind.
Yeah, so these commands will all be for Mac OS and for Linux. There will be a parallel set of commands at the end of these slides that you can look at if you are on Windows. So then that'll be different for you if you're on Windows. Alright, so the first one is print working directory. And you can do something that's called mkdir. It's called making a directory. And when you type that, you make a directory called my app. I said make directory my app. And you can change directory, which is cd, into the my app. So this is sort of like a navigator for all your folders and files. That's like not in the usual way that you see like folders and files inside. So you don't have to click on it, you type what you want to do. So now you can do print working directory again. I just changed directory into my app, so now I'm in the folder called my app. And so if you look on your file explorer, whatever it is that you guys use, you guys will see that in my home folder, I now have a folder called my app. And now that you're inside this, there's a bunch of things you can do. You can call touch. What touch does, it just creates a new file that's empty with that name that follows it. So if you call touch myfile.js, that'll create a new file called myfile.js in your files. So that's straightforward enough. And if you call ls, ls lists all the file in a directory for you. So in my app, I call ls, and now it says myfile.js is one of the files inside. Cool. Anyone do these right now? Okay. So now what you can do, there's this other command called move. You can mv, and what it does is that it moves the file from location A to location B, or in another way of saying it, you're changing the name of it, if that makes sense. So you're saying that I'm going to move myfile.js to ABC, or you're renaming to ABC. So now if you show the files again, you'll see that only ABC is in the file directory. And now there's a bunch of other commands you can do. There's copy, which is CP. You can copy ABC to XYZ, and then now if you show the files again, you have ABC and XYZ, which we know all originated from the file myfile.js, and it's all empty because we didn't do anything to it. Yes. And then now we can remove things in the same way. RM is for removing it. So terminal is just like a quick way, like for you to interface with the computer using typed text instead of you actually clicking and interacting with it. So now like there's print working directory again. We're back at the my app folder right now. And when we say change directory to dot dot, what dot dot means is the parent directory. So you can see when we're in my app and we call cd dot dot, that'll bring us back to our home folder. Yes. And there's a function for removing a directory, rmdir, and then you can do that too. And then you can just, when you try to cd into, when you try to change directory into the same folder, you'll see that's not there. Yes. This is very quick, but this is the same equivalent things. So like on the left are the commands for Linux and Mac OS, and then on the right are the commands for Windows. There's a lot more commands that you can use within the terminal. You can look that up, feel free to look that up. These will be the key things though. There are a lot of them, but there will only be a few that we'll be using for Git. Cool? Everyone's that far? Alright, so now we'll actually talk about Git. So let's start with a story. Let's say we have this person here. Let's call him Bob. And now let's say Bob has a file. And Bob has a friend. Bob's friend is Joan. And Joan's like, yo man, I see you got a dope file there. So Bob is like, okay, let me send you this file. And Bob sends the file through email, and Joan receives it. And Joan makes some edits because Joan is like, I don't know, a perfectionist, and he's like, oh, you know, like, this can be better, you can do this. And now Joan sends the file back to Bob. Yay. Alright, so this is like a story of like how collaboration would work in like back in the good old days of like, you know, emailing and stuff like that. So now the problem is we are working on coding projects. So now let's say instead of just like a regular document, you have a coding project. And instead of having one file, you usually have like a lot more files. And in order to keep your files consistent, what you can do is what files that Bob has, Joan also needs to have. So now you have like a lot of files that you can make sure that stays consistent. So what are the things that can go wrong if we just use our emailing scheme of sending files back and forth? So there are 3 problems I like to say. I'll just go over them one by one. The first is synchronization of files. So let's say we have a bunch of files. Bob has a bunch of files, Joan has a bunch of files. And now Bob is like, wow, there's a bug in line 3. So Bob fixes it, but Joan doesn't know. Joan's like, okay, this is the end of IAP. We're going to submit our website now. So now Joan submitted a buggy website. Sad. And that is because there's no way of noting which file and which version of files is most updated. And there's no way of telling everyone on the team that, hey, this is the version that we want to submit. And so that's the thing that's bad. No one knows which file is the most updated file. So now we go to the second problem, collaboration of files. So let's say we have Bob and Joan again. They have their files. And Bob is like, there's a bug here. And then Joan's like, this formatting is pretty ugly. So they modify some files, and you can see one of the files that they modify is actually the same file. So now Bob will realize that our code is different. So what do you do to solve it? Bob is like, hey, I know you made changes in like 50 places in this file, but can you just copy it over one by one? Because, you know, we need all those changes, but like, that's pretty annoying. So now Joan is sad because Joan has to copy over 50 changes one by one. So that's the problem with collaboration of files. If there are 2 versions of the same file, both of them fix a different problem, it's hard to know how to join the files. And now, the last problem is version history. I'm sure some of you guys have already faced it before. You're working on some code base, and you're like, hey, let me change some code. And then you like delete a bunch of lines, and you add a bunch of lines. And then like an hour later, you're like sad, because I needed those lines. And then you like forgot, and you don't know how to get them back again. So now everyone's sad. Yes. Okay, so now if we break something, we can't go back to it. That's the third problem. So now how do we solve these problems? And that is why we need version control. And that is what Git is. So instead of the scheme of like emailing files back and forth like we said before, we have each user interact with Git, using Git with the Git server. So now we send files to Git, and now everyone on your team will similarly interact with the same Git server. And how does this work? So let's say you have Bob here again, and Bob modifies the second file. What happens is that Bob sends this file, and Bob makes changes in the second file. And what this is called is a commit in Git. So a commit is a set of changes. So you can say like, I added line 2. That like can be like a set of changes that you made to a commit. So now you send these commit to a Git server, what we call push. So just a review, whenever you make changes, you can make it into a commit. And what a commit is, it's a list of changes. And when you push it to the server, you're telling the server, hey, all my files should now have these changes. And so now the Git server receives these changes. And now similarly on Joan's side, let's say Joan is working on the same project. Then Joan will do what is called a pull. So what happens is that Joan gets these files, gets these changes from the Git server, And now Joan will see that, oh, okay, so I see you add line 4 here and you're doing line 5 here. So now Joan can update her files to reflect what has changed in the files. Okay, so now just to review some terms again. So a commit is a packaged set of changes that Bob made to his files, and then he pushes these to the Git server. So basically he sends these commits to the Git server, and Joan, the other person working the project, will poll to get the most updated files from the Git server. And when she polls, she gets all the commits, and then Git will do all the updating of the files. Okay, so now let's say in the same story, later in the day. So now Joan is working on some code. She changed it. So she changed files 1 and 3. And now she makes these into a commit, like we said before, and then she sends it to Git, to the Git server. And Bob on the other side, Bob also makes changes to files 1 and 3. Maybe he's like, oh, I think this is the way it should be changed, but they didn't talk to each other, so they made similar changes, or maybe they made different changes, who knows? So what happens is that Bob also makes a commit, and Bob tries to send it to the Git server. And now we have what is called a conflict. So what happens is that the Git server will notice that Bob doesn't have the most up-to-date version of the files within his local files. So Git will force Bob to take take the changes that are currently on the Git server, merge them, or deal with them, and fix conflicts himself. And then after that, he can push it back to the server. So it'll look like this. So now we have a conflict, and now Git will be like, no go, you gotta fix these files. And Git will send the updated versions as sent by Joan to Bob. And now Bob will merge these two, or change these two somehow to make one file. And then so now Bob can commit these changes and push them to the Git server again. Do we have any questions so far? All right, cool. Okay, so now let's try this ourselves. And first, we need to make a Git repository. So what is a Git repository? So it's a folder that you tell Git to keep track of. So once you make something a Git repository, Git will be able to be like, hey, you added a file, do you want to send this to your teammates? Or hey, you changed something, do you want to send this to your teammates? So this is a way for Git to keep track of your code. And so now, if you're on your terminal, this is what you can do. You can say, make directory my app, as we said before, something like this. And you can change directory into my app. And now let's say you create a text file called mypage.html. So now we are in this folder called my app. It's empty other than for this file called mypage.html. So what you can do is you call git init. And after you call git init, it initializes an empty Git repository. And you're like, what does that mean? Let's say I'm going to call ls, and I'm going to see what happens. So actually, if you look at it, if you call ls, which is listing the files in the directory, you're going to see that it only has mypage.html. That didn't change from before. But if you call ls-a, you're going to see that it has a few more things. So what ls-a does, so ls is the command to list all the files in the directory. With -a, you can show all the files that are hidden, which are in Linux, in most Unix systems, it's files that start with a dot. So you see there's a dot folder, there's a 2 dot folder, and there's a .git folder. So the .git folder is what Git added. So essentially, Git added a hidden folder into your directory in order to keep track of what is going on there. Cool. And so now let's say we call git status in the Git repository. So it'll say that you're on branch master, there's no commits yet, and you have this new file that hasn't been tracked yet. It's called mypage.html. So let's say you're working on a group project and you just made this page. Clearly you want all of your friends and all of your project mates to be able to see this, right? So now what we do is we're going to follow the steps to create a commit and then push it to the Git server. Now let's do this again. We call git add mypage.html, and then you call git status again. So when you add a file, what it does is it's preparing it to be committed, if that makes sense. So usually when you send a commit, you do a commit of more than one file. So what you do is you add every single thing that you have modified so far, And then you can check the status of it, and you can see it's a changes to be commit is in my page.html. So after you add it, now you can create a commit. So you can call git commit -m, my first commit, for example. And like that, the my first commit is just whatever name you have for your commit. So like in the future, like let's say like you're 10 commits in, you can be like, oh, your commit message could be, I added a new button, or like, I made a database work, or something like that. And yeah, anything of the sort that tells you what the commit did. And so there's a useful command called git log. So when you call git log, what happens is that you can see a list of all the commits so far. So if you think about it, your code is basically like whatever starting code it is, plus 100 commits. Because commits are changes, right? So you have a set of changes A, you have a set of changes B, and etc. And that stacks on top of each other. So right now your code is nothing except for your first commit. Anything like that. So so we have created a local repository. What we need to do is we need to find a space on the Git server to store all this information, right? Because all of the stuff that you're doing right now is local and you haven't sent it to anyone yet. So to do this, we all need to go on GitHub. So if you go on GitHub, I think all of you guys should have GitHub accounts. So if you go on GitHub, and then there's this blue button on the bottom right that says new repository. So if you click on it, then you get a new repository. Bam. And so if you click on it, you'll get to this page. And there's just two things you really have to know. It's just that the name of the repository, and then you click create repository. And the name of the repository will be shared among everyone. So like, name it something appropriate to the project. Like if you're doing like a science project, be like, I don't know, Science 2018. I don't know, something more memorable. Yes. So after you click create repository, you'll come to this page. So notice that there's like a few options to like do what to do. So notice that we already created an existing repository. All the steps that we did before is to create an existing repository. So we only have to follow these two commands. And these two commands are, in a sense, they're telling your local Git files where to send your, where to send your commits. So you see, like it says git remote at origin, and that link is specific to whatever repository you have on GitHub. Alright, so now we go back to our terminal, and then now our command line, yeah, and then we type these two commands. We can just copy and paste it. So when you're on the page, you just copy and paste it. So now you do these two commands. So now it'll be like done. You paste these commands. So just a review, what we did is we created a new file called mypage.html, and now we added it, we added it to commit, and we created the commit. And now we have sent this commit to our local, to the Git server that is hosted on GitHub. So now if we refresh our github.com page, we're going to see that it no longer has the what to do things. Instead, it says you have one file called mypage.html. So yay, you just sent something to the Git server. So now if you think about it, you're a teammate, you can go to this page, and now everyone can access the file similarly. Awesome. So now let's go sleep. Okay, so now let's say we wake up a day later. We're working with some friends, and then now we're like, oh, okay, I'm going to add something to my page.html now. So you open them, and you're basically you type this into my page.html. I don't know how to make a website, so I'm just typing random stuff. And then you're like, okay, I'm going to call git status, so Git is going to tell you, you changed something in my page.html, so now you need to make a commit. So, as from before, in order to add the commit, or in order to make a commit, you call add my page commit -m and then call git push. And now notice that we have a bunch of error types. And I think the most important thing to notice is, okay, so whenever Git goes wrong, it throws you a bunch of messages. It's a lot of words, but it's very important that you read each of them so you make sure that you know what's going on. So it says, updates were rejected because the remote contains work that you do not have locally. So that means that tells me that someone else has changed the repository. So if we remember back to the Bob and Joan case, that means that there are new commits on the Git server that I have not retrieved yet. So I need to do that. And to do that, I call, oh, okay. And now if we go on the web page, we can see that someone added the home page instead of our first initial commit. Looks like someone changed the website. So like someone else on the team has sent a commit from somewhere else to the same repository, and now it says that you have this like error. So what you do to resolve that, you call git pull, and git pull, Git will tell you a bunch of things. It'll be like, oh, you're like pulling things. And sometimes git pull is enough. Sometimes you can call git pull, and they'll be like, everything's nice, you can just push again, and everything will be fine. But in this case, notice that we have this thing that's like in all caps, it says conflict. It says, merge conflict in my page.html. That means that whoever my teammate is also like modified my page.html, and now something's broken. So what I need to do is I go into my page.html, and now you can see there is a bunch of marker text, but essentially what you can see is there's a code that you wrote, and then there's a bunch of other code that other people wrote. So do you guys see like the left arrows, and then the equal signs, and then the right arrows? Yes? Yes. So the things between the left arrow and the equal signs, it says head, and head is your changes. So you see, you type the text, I don't know how to make a website, so I'm just typing random stuff. And from the equal signs to the right arrows, you can see there's a bunch of code. So essentially what happened was that your teammate actually did some work and made a website. So now what you need to do to fix the conflict is you need to keep the version that you want and delete all the marker text. So we need to delete the arrow stuff, the equal signs, and the arrow stuff, and also the version we don't want. So let's say we're like, oh wow, our teammate did a good job. I'm actually just going to delete my message now. So now you remove all these things, and you're left with this. So you save the file, and then now you call git status again. Now Git will say like a bunch of things. Basically, what happens is that you modified the merge version of the Git file. So now what happens is that you need to add and commit it again. You call git add. You can check Git status to see that your workspace is clean. In other words, you have added every single file that you want to be changed. And you call git commit, and you call it the right web page, and you call git push. So now everything's clean. So in a sense, you just retrieve the updates that your teammates did. You merge the conflicts, and then you push the merge conflicts, or like you push the merge file back to the server without conflicts. Yes. Okay, so now let's go back to our handy-dandy command and call it git log again. So if you call git log, you notice that the bottom is still your first commit, and then someone, aka your teammate, called added homepage. So what your teammate did is your teammate added the homepage, and then you had a commit that's called I tried to make a web page, which is the message called like I don't know how to make a website, so I'm just typing something random. And finally, you have a commit called write web page. So these 4 commits are the changes that have happened to your website so far. And you can always call this command to go back to it and see. And just to recap, these are just like a bunch of useful commands that you can use. There's like to create a local repository, this is what you do. To set the local server address, this is what you do. Send changes, get updated files, and also useful things are just called git status and git log to see what's going on. Yes. And now we will move on to the next class, which is Intro JavaScript.